Hey everyone, this is the final project for GAM 490, which is multiplayer game development. And in this class, we had to take an existing game called Omega Race and we had to make it networked and add network capability so that it can be played on two machines. For the purpose of this demo, I'm running two instances on the same machine, and I'm defining the server port and the IP address as localhost. So first off, if I start off the first instance, it's gonna try to find an already existing instance on that IP address and on that server port, and if it doesn't find anything, then it becomes the server. So, and it can't start, so I'm pressing spacebar to start the match. It can't start it because there's no other client connected to it. There's no connection. So if I start the second instance, now it's connected. The client can't start it. The server has control. So if I press spacebar, the game is started. The server controls the green ship, and the client controls the blue ship. The missiles, each ship can fire up to 3 missiles at a time. And so the game is data driven, meaning that there is an input queue and an output queue. So whenever I'm moving the ship, firing the missile, placing mines, collision, all these are data driven. So I'm letting the client know that something's happening. The server handles all the physics, so all the physics bodies that have to deal with collision and with hit detection. That's all dealt on the server side. The client simply updates the sprite, the game object, and updates the sprite's position in the game screen. And all of the updates for the ship movement is done in the push to physics in the update method for the game object, and it simply checks to see is there a physics body for this game object, and if there is, then it's going to update the position and push that and add it to the output queue, and then the output queue sends all these messages over the network to the client side, and then the client side processes that, and it's in the client's input queue, and vice versa. The server also handles and does all the calculation inside its input queue within the process method. Okay, and this game goes first to 3. So I'm trying to play first and win as player 1, and then I'm going to win as player 2, and I'm going to see if the mines work. I'm going to show how the mines work really quick. So I'm going to push this and place some mines if I can. Hopefully that works. It's not armed. The mines have to be armed, so it wasn't armed. So I need to wait till it gets armed. Now they're armed, they should detect. There you go. So that's when the ship is destroyed. Each ship has 5 mines to use. So I'm gonna try to win really quick. And I'm using the keyboard. So now player 1 wins. So now the game state has changed to the game over screen, and in this screen, the client cannot do anything by pressing the spacebar. Only the server again has control to start the next match. So if the server player presses the spacebar key, it launches back into the lobby screen, and then again the client cannot start the match. Only the server can, so the server restarts it by pressing spacebar. So now I'm going to be controlling the client. So client is the blue ship, and I'm going to win hopefully as the blue ship client. And again, it has 5 missiles, 5 mines I mean, that it can use. And I'm going to try to kill this player with this mine. So if I try to predict where it's going to go, hopefully if they're armed, once they're armed, it hits. There you go. So the mines work. I'm gonna try to win this right now. And again, whenever the ship wants to move, the client sends that information, sends a message to the server saying, hey, I want to move the ship. And then the server handles the physics, and then it sends a message back saying, hey, this is where the new position of the ship should be. And then the client gets that message, and then the client updates the ship position inside the input queue. And that's how it's data driven. And again, the server client can only shoot 3 missiles at a time, and again, it's first to 3. But all the collision, and in terms of collision, the collision is handled locally. It's just that when there is a collision between 2 objects, the server lets the client know that there is a collision between these 2 objects, and then the client gets that message and then finds those 2 game objects and then does the collision handling internally. The fence and the fence posts are done internally. The only networked objects again are the ship, the missile, the mines, and the collision, and the logistical data such as the player score, the mine count, and the ship count, and the life count. So again, now player 2 wins. Client cannot control the game state change. Only the server can. So if the server presses spacebar, it launches back into the lobby screen. And so now we're back to the lobby. So hopefully this gives a good glimpse of the data-driven aspects of this game. I'm just gonna show a little bit of the code here. So when the game first starts up, it's I define the server and I define the client, and every instance of the game first starts off as a client, and it's I create the client, and then I'm finding the IP address and the port and trying to connect to it. If nothing exists, then it becomes the server, and that is done through the incoming messages in the game manager. So as I'm going here, so the client is trying to find the net incoming message type status change, and if it finds this and then the status is disconnected, it becomes the server. If it's not, then it's already connected, and then it becomes the client. And then in my update method, or in the game method actually, game class, it's loading the content, and then it's updating, and if only if the P server does not equal to null, meaning that this instance is the P server, then it updates the physics simulation and does a physics simulation, and then it goes into the game manager update. And this update, it goes through and it reads incoming messages, and it also handles the different types of screen updates methods. And in the load screen, it checks to see if the server has pressed the space bar, and if it does, then it's gonna add that to the output queue, clear the output queue, and then send the messages in the output queue, clear it, and then the input queue will process those messages that come in. And in the play screen update, we're doing the same thing. We're processing the inputs for the server, which is the firing of the missile, the movement of the ship, the rotation of the ship, and the laying down of the mines. And then I'm also testing ping. I didn't get to really fully implement this, but I will use it later on, because this will be used to sync both the server and the client so that there's very minimal lag. And you will basically add that delay between the input queue and the output queue on the server side. And then we're updating the game objects. And then our update, we're checking to see does a physical body exist, and is this the P server? And if it does exist, then we go into the push physics method, and in here we're doing all of the adding of messages into the output queue. So we're adding like the ship movement, the missile movement, the mine. Well, for the mine, we don't really need to change it too much because it's in a stationary position all the time. So we don't really need to update it as much in terms of the physical body. And then that is added to the output queue, and then the output queue sends these messages, sends the data across to the client, or to the other party, and then it's also added to locally to the input queue. And the input queue within the process method, we have the messages, and based on the type of data that is being sent, it detects and it does all the process handling, and it changes based on if it's a server or if it's a client. It changes the position or it changes the property of the game object. So hopefully that gives a good glimpse about this project in terms of networking. I thoroughly enjoyed it. This was an amazing class. I learned a lot about networking, about TCP, UDP, and by the way, this is using all TCP, so it's all reliable. It was a great and fun class, and this project was very eye-opening into the process of multiplayer game development. Hope you guys enjoyed.